Our assignment was bin packing, and the first learning target that we will explain is first fit. So first fit is basically you have your whatever you're trying to get in your bins here, and then this one in particular you can only fit 12 in there. It could be different for other ones, but just for this one it's 12. So for the first one, 6 is going to go in the first box, and since it's 12, 7 is not going to be able to fit in here because it's 13, so you have to put it in the next one. And then 5, it can go in the first one or the second one, but you're going to get to go with the first one here. It's 11. Then 6 can't fit in the first one or the second one because it adds up to over 12, so you're going to want to put it in the next one, next open one. And then you have 8 here. It can't fit in either of the first 3, so you have to put in the next open one, which is 8. And then first fit decreasing is the next learning target we'll talk about. The only difference in this is you're going to want to take the numbers and put them from greatest to smallest. Same thing here, you can only fit 12 into each bin. So 8's going to go in the first one. 6 doesn't fit in the first one because it's over 12, so you're going to have to put it in the next one. Same here, it's not going to fit in the first, so you put it in the second one. 3 can go in the first one because it's under 12. And then 2, you got to put in the last one because it won't fit in the first 2.
Alright, the next one is next fit, and in ours we're going to have 10 per bin, and there's no looking back in this one. Once your item doesn't fit in the bin you're currently on, you got to go forward. You don't go back. So in this example, 9 would go in the first bin, and since 4 doesn't fit, because it'd be over 10, you put 4 in the next bin, and 6 would fit in this bin since that it adds up to 10. That bin's closed. 8 would go in this bin, and 2 would also fit in this bin. And example for this in real life would be if you're at like a hotel or something. There's like a hot tub. They have like capacities for that. So once the hot tub reaches its capacity, you got to go to the next hot tub. You can't just all cram into one. Alright, the next one is next fit decreasing, and it's the same as next fit, just you want to get your numbers in the from largest to smallest. So this one's going to be 10 again. 7 would go in the first bin. Now 6 would not be able to fit into that one, so we'll put 6 in the second. Then the next 6 wouldn't be able to fit into this one, so we'll put 6, the second 6, into the third bin. 5 and 4, these two add up to be 9, so these two can fit in the final bin.
The next learning target we're going to talk about is worst fit. What worst fit is you're going to take the bin that has the most room in it, and that's what you're going to put the next item into. For this one, you can fit 13 in it. So we're going to go ahead and put 10 in the first one, and then 4 is not going to fit in the first one because there's not enough room, so you're going to put in the next one. And 3 could fit in this one, but you're not going to put it there because it doesn't have the most amount of room, so you're going to go ahead and put it in the second one with 4. 8 isn't going to fit in the next 2, or the first 2, so you're going to put it in the third one. And then 2, you're going to want to put in the second one because it has the most room rather than the first or the third one. And an in-class example that we had was FedEx or UPS. They try to even it out by putting boxes in, try to even it out and not just have like a lot of boxes in one truck and then have not as much in the other truck. They try to even it out and have about the same amount of items in each truck. And then worst fit decreasing is basically the same thing as worst fit, except you're going to put your numbers in order. So 8's gonna go in the first one, and here it's still gonna be 13 in each bin. So 6 is not gonna be able to fit in the first one, so you gotta go ahead and put that in the second one. And then 5 isn't gonna can't go in the first one because the second one has more room. 3 is gonna go in the first one. And then 2 can go in either the first or the second one. It doesn't make a difference because they both have 11 in each. So I'm just going to go ahead and put it in the first one.
Alright, the next one is best fit. And for this one, the order doesn't matter. It's just you want to take your numbers, and in our example, we're going to have 10 per bin. And you want to group them so they equal 10. Like right off the bat, 5 and 5 equals 10. So we'll put 5 and 5 in the same bin. Just cross them off. Next, 4 and 6 will also equal 10. So we got 4 and 6. And then all we have left is 8. And that can just go in the last bin. An example for this in real life would be for if you got like a class going on a field trip, they want to do best fit to pair up everyone and make sure that the buses are more equal. There's not a lot of kids in one bus and then not too many kids in another one. And finally, we have optimal vertex. So with this, each letter is going to get a shape. And if there's a line connecting two letters, then those two letters can't have the same shape. Now we already did this one, but I'm going to explain how we did it and why we did it the way we did. So we started off by giving A a star, and then B, C, and E can't get a star because there's a line connecting them to A. So what we have left is F and D. We gave the star to D, and then F couldn't get a star because there's a line connecting D and F. The next one we did was circles, so we gave it to B, and there's no line connecting B to C, so we gave C a circle, and then there's no line connecting F to either of those two, so we gave F a circle also, which only left us with E, which we just gave a rectangle. A way they use this in real life is for like a zoo. If there's two animals that would eat each other, they can't have those in like the same pen, so they switch them up so they're not together.